There we go. So let's turn this down a little bit. So yeah, welcome to the stream. I've got a few things. I did a few things off stream just to like get stuff ready and prepared. But yeah, this is gonna be the start of a few streams that I'm gonna be doing, of just going through like from an empty Kubernetes cluster all the way up to, you know, fully fledged, you know, CI/CD, GitOps, you know, getting everything that you need to set up from, you know, as you can see, just a pretty much blank Kubernetes cluster. So if you were setting this up for, you know, on bare metal, or if you were just getting something from a cloud provider like Linode or AWS, and you were starting from, you know, nothing, just going through all the different, just going through all the different considerations and services that you need to set up and be aware of, so that you can be, you know, successful in setting up whatever you really want to set up in your Kubernetes cluster. So yeah, just a little bit of background. Like, this is if you haven't worked a lot with Kubernetes, or if you just are kind of getting started with it, or you're just kind of understanding it, this is a tool that I really like to use called K8S. Basically, it's just a terminal-based viewer for Kubernetes. So it allows me to, you know, read and view all the different resources that I want. So I can swap between my namespaces, I can see the pods, I can see deployments, I can see, you know, whatever I'm really interested in. And it's a tool that I've gotten used to and that I use. So I'm going to be using it quite a lot during the streams. And not super relevant for the stream itself, but I wanted to show what the cluster that I'm going to be using, how it's set up. I'm running a little Proxmox box in my house, which is just a virtual hypervisor, so it allows me to build virtual machines and connect them together, and it's just a way for me to separate out the resources that I'm going to be using for the stream from, you know, my normal lab stuff or from my home computer. But you can spin up this Kubernetes cluster just about anywhere. So if you wanted to go to, you know, Linode, you can spin up the exact same thing in Kubernetes. You could spin it up with EKS in AWS, or if you're more familiar with like Azure or Google Cloud, you know, anywhere that's just going to give you a Kubernetes cluster to work with will work for getting started on this. Hey, thanks for the look, man. Appreciate it. But yeah, it's gonna be a lot of fun. Gonna be a lot of interesting stuff to get done. But just wanted to get kind of that little background out of the way, that, you know, this is how mine is set up, but it can be whatever you want to have set up. So the first and foremost thing that we need to get set up is how we're going to actually be deploying to this. And there are a couple of things that we can do. Typically, when you're starting out in Kubernetes, you're just going to be doing something like kubectl apply, which is basically just setting up some files with a spec and running those files against your Kubernetes clusters. And that's okay for your kind of quick things, just really need something to get started or really rough and ready in a lab environment. You can kind of go a step further and you can start working with Helm, which allows you to sort of package up a lot of those templates and present them in a way that is more distributable. You can have values and templating. And that gets you a good amount of the way there. And there are other technologies like Kustomize, which give you kind of the same thing, of a way of storing those files and those resources in a way that is easy to template out, easy to push out, easy to manage. But it doesn't really solve the problem of we're still having to run some command in our terminal that's going to apply these resources or these manifests to our cluster. And so that's where we go one step above and we want to get a deployment system. So the one that we're going to be using for these streams is one called ArgoCD. It's the one that I like the best and that I've used the most. There are a lot of other ones like FluxCD, I know is another very popular one. And they basically all do a very similar thing. They want to give you a way of setting up usually a Git repository that if you point the tool at that repository, whether it's the first time or the 10th time on one cluster or 12, you'll always get the same result. So it allows you to put your configuration, your infrastructure in a Git repository and say, no matter what, this is what is going to, I want this to be the source of truth for what is in my cluster, so that if someone comes in and wrecks my cluster or something happens and the cluster's gone or, whatever happens, we can go and take this cluster definition, this repository and source of truth, apply it again, and we'll get exactly the same result. So it makes it really easy to recover, really easy to manage. All great things. So, like I said, we're going to be using ArgoCD, and we're actually going to be using a tool that they wrote called ArgoCD Autopilot. And the cool part about ArgoCD Autopilot is that it solves kind of a weird problem that you have, where when you set up one of these deployment systems, you find yourself in a position that if you do need to recover or you need to jumpstart yourself again, a lot of those steps are going to be manual. You have to manually set up the deployer, get it connected, do all that. And ArgoCD Autopilot's a really interesting solution because it will not only deploy ArgoCD, but it will then add ArgoCD to itself. So when you want to recover, there's no manual step. You run one line to point it at the repository, and you're done. And that's pretty much it. So this is where we're going to start, and just kind of going through the basics of ArgoCD and getting our GitOps platform kind of set up. And maybe we'll get some simple stuff deployed in this first stream. So what I want to do, I've already got it installed, so we'll go to the getting started. So I'm just going to go off to the side and grab a GitHub token for me to use because I really don't want to expose that. So bear with me for a minute and I'll just grab one of these tokens. Let's see. We should only need it for this initial bit, because after that it's going to be... After that it'll set up whatever we want. So just give it the right scopes to make our repository. So I'm gonna have another terminal open over here just to run those commands real quick. Alright, so I've got that open, and I think I should be able to do, if I do this, So let me just do one thing really quick. Check. No, okay. So I'm gonna pull this in. So I have the Git token in here. And we're gonna set a fish autocorrect. How fun you are. I'm gonna be revoking it right after this, so I'm not terribly worried. So I'm just gonna set up the Git repo, kind of how this is. github.com/me. And we're gonna call it just like stream K8S lab. Just so that yeah. I gotta remember I'm using fish. So now ArgoCD boot pilot repo bootstrap. So what we should see, and actually let me open up another terminal so we can kind of see this working in real time. So you can tell the pods, so it's gonna install ArgoCD, create the Git repository, and get everything kind of bootstrapped so that we are good to go from there. So let's see. So yeah, we'll be able to set up a few things. So it'll create everything, set up all the ArgoCD custom resources, and we should start to see the pods, pop up here in just a second. And we should actually be able to also see in my GitHub, we should be able to see, stream K8S lab, and I will actually make this a public repository here soon, so that anybody can go and find it and take a look and see if they want to follow along. Alright, so now we got our ArgoCD set up. This should have some nice code pushed to it. So so I'm going to go into my repositories folder and clone this down so that we can work with it locally. And then, I screwed up a little bit because I went over before I got the secret. We can go and grab that out here. So we're going to port forward into our ArgoCD svc / ArgoCD server so that we can go to our local host and we'll see our ArgoCD. So it should be like admin and then this password, I think. Yeah, and there we go. Now we can kind of see our initial ArgoCD and how this is kind of working. So root is our root application, which I believe, if I remember right, is our... we can go and explore the repository, right? We can kind of see how this is all working. Code, stream K8S lab. So we can pull this up side by side with ArgoCD and just see if we can figure out what's going on here. So we have the bootstrap here, and we have our root application. And we can see this is basically just setting up our projects. So it'll be everything that's in here. So this is going to set up every application or project we want to deploy is going to have something in here. So we can make a new project like that through their kind of autopilot CLI. So let's go ArgoCD autopilot. We can kind of look through their CLI and see if we can get some stuff going. So command reference right now. So this root is going to be every time we want to deploy a new application or do something, we can make a project, and that'll get synced through the root. So, okay. So we can kind of see that through all the ArgoCD stuff. And I'm not going to worry too much about like explaining all like the particulars of the ArgoCD stuff. But I will explain kind of the basics of the ArgoCD is kind of built around this idea of applications. And it's a pretty straightforward thing. You have a cluster that you want to deploy some resources on, and you have a source where those resources live. And basically what it's going to do is look at that get resource, see if it matches what's in the cluster, and if it doesn't, it'll make sure it does. And that's what this sync policy here is for. And that's really all it's doing, is it's going to look in our projects, see some resources, and sync them to our default cluster, which is just where it's running. So that's our root application. Okay. We have our clusters in resource, which is kind of a application that is going to... It's kind of doing that like cyclical setup where it's going to look at everything in cluster resources to set up. So this is setting up like a namespace and a couple of other default clusters that it can talk with. So it's making sure that kind of the things that ArgoCD expects to be there are there. Then we have our Bootstrap. And this is what is actually managing ArgoCD itself. So you can see it has our other application root and our cluster resources that are set up here. So this is like the application that it created to manage itself. And then finally, we have the ArgoCD, which is just our ArgoCD deployment. It has all the services, all the custom resources, all the deployments, everything that makes ArgoCD itself run. So that's all fine, and for most of the time, we won't have to touch any of this. This is just stuff that it created that is going to be what we kind of deal with later. So what I want to know, now that we have ArgoCD set up, and it's kind of given us this thing here, and it's given us two main things. So we have an application, and we have a project. So we can kind of read what it's expecting us to do with these. So applications are going to be our individual components that we're deploying, right? So if we want to deploy Hello World or a, radar or sonar or any of these other self-hosted applications, we need to do it through an application, and that application will be connected to a project. So we can see these kind of application and projects. So I think first thing we want to do is just kind of play around with this. And based on what I'm seeing here, is it wants us to make a project first. So let's do that. We can kind of work through this. So yeah, so we're here, right? We've bootstrapped ArgoCD. We are logged in. Yeah, and we can see all the things that it created. So let's create a project. So we'll just create some testing project for now. And let me make sure that this has the token. Okay. So we should be able to say ArgoCD autopilot project create testing. And we'll look at our root for right now, because that's what's going to hold all of our project definitions. So we create a testing project. It'll create some stuff. Don't see exactly what it did yet, but we should see, oh, there we go. So if we kind of do a git pull here, we'll see that it created a testing.yaml with a bunch of things in it, and it automatically synced these resources to our cluster. So what is the next thing we want to look at? We want to see what it made. So it made a project, which is our testing project. It tells us what server that project belongs to, some sync options, a sync wave, and it made an application set. So it's going to look at everything that is in the apps, anything that says testing, so the testing environment, and deploy that. Or a config dir.json. And it'll set up a application in the testing project for that. So what that tells me is that it's saying ArgoCD Autopilot is kind of using projects as our environment, which might be what we want. And I think for us, since we only have one environment, I don't think that's going to be exactly how we're going to do it. So I think we're going to use projects more like applications. So in that case, we can kind of take a look at this and see how we want to move forward. Because I would like to continue using the CLI to do this stuff as much as possible. So I guess let's look at how they do applications. So let's make our Hello World application here and just see how it works. So it'll clone, it'll pull some stuff in, and we should see something in our applications should show up in a minute. Let's see. Let's see if we do a git pull, do we see what it made? Okay, yeah, so we can see hello world, base, overlays, testing. Okay, so it created a base that pulls from this repository, the customized code from that repository. And then this is using that as a base for an overlay into the testing project or environment with these kind of parameters to set it up. So I don't think that's the worst way to do it, like this as a base structure. But I think we're pretty much always going to have one project if we do it this way. Which may or may not be a bad thing. You know, we'll have to do these kind of labels more. So name hello world gets us this, right? So that's an option. And I think that's what we're going to go with for now, just because it makes it much easier to go forward. So we've got our hello world, and let's see what it looks like in the cluster. So like if I go into the cluster, we can see where is it? Does it not have any? What resources did it deploy? So yeah, okay, we have our simple deployment here. And that's our hello world simple deployment pod. Memory issues. That's no fun. I may have to increase the memory on each of these. I've got enough memory. I'll do that at a later time. We're just kind of playing around here. So I definitely need more memory per node. So okay, so we have the ability to deploy applications. And we have kind of a GitOps section that we can work with. So let's use, I'll leave hello world as a base, but I want to start doing my real stuff now, like ArgoCD, autopilot, project create. I want to create a project that's going to be my production, right? My production deployment of this. And that's just going to be where, for our home lab, everything's going to be production. And maybe later we'll go back and make a staging environment where we can sort of plan things ahead. But since we only have one cluster and everything's going to be in that one cluster, I think it makes more sense to just have everything is going to be our production instance, our production project. So we got this production set up, and we have some production projects set up. So that's working. And I think now we need to start thinking about what kinds of things you want to set up. So let's go back to our project, right? Let's think about what kind of projects, what kind of things we need to deploy, right? Our stream K8S Homelab. And we'll make a little list. So there's a little bit of infrastructure that we need to deploy first. First thing we need is something that will allow us to assign external IP addresses to our services so we can access them. Because we don't want to have to port forward into everything. So we want to be able to give domain names and IP addresses to our services just like we would in a virtualized home lab setup. So that's kind of what we need. And what this is, the most popular one of these is a service called Metal LB. So we need a bare metal load balancer. And we're probably going to use Metal LB for that. And what that really gives us, if you're in the cloud, you won't need to do this. So this is something that we're doing because we're making a home lab that is bare metal. We need to kind of go and make, supply some things that we don't typically have. So the other thing that we need to set up, because we're not in a cloud environment, is some kind of storage class. And I typically use Longhorn for this. And what this storage class is when we want to have storage where we want to give disk space to a pod or a service or whatever, it needs some way to provide that. And typically you'll see like that it'll give like host space. But that's not really what we want to do, because if we move these nodes around or we expand or contract or something gets messed up, we want to make sure that that data is available on all the nodes and is being properly replicated across them. So if one of our nodes fails, we're not dependent on that node for keeping the data. So like I said, I like to use Longhorn for this, if I could spell. And it essentially allows us to use the native storage on all of our nodes as this distributed block storage. So those are the two things that if you're running Kubernetes in the cloud, you're typically going to get a lot better support for. They'll have load balancers for you. They'll have block storage available for you. But since we are running on bare metal, it's something you want to set up. And I think it's also really interesting to set up and kind of understand really how this stuff works. So with that being said, this is kind of our like infrastructure set. So like this is our This is more like infra or bare metal infra that we need. And then there's kind of things that we need after that. So next thing we'll want is some kind of ingress controller. I really like using traffic for this. Just because I've used it the most, and I think their dashboard is really, really helpful for keeping track of things. So this is like our other... This is like bare metal infrastructure, and this is our general infrastructure. And what this ingress controller is going to do is make sure that when we create an ingress, it's able to be routed to the right place. So we can just say, hey, I made an ingress to go to my ArgoCD with this domain name. And it'll say, okay, all the traffic's going to come to me first, and then I'll make sure you get the right traffic for you. So we're going to need to install traffic. And it'll give us, I can kind of give you an example of what I have set up. So this is part of my Homelab and some of the services that I have set up. So you can see it has all these rules for different services. So whether it's Prowler, Longhorn, my DNS server, NZBGet, Sonar, Radar, all these things. And then it has an associated service in Kubernetes that it's routing to. So we can kind of drill into this Sonar, right? So it says, if I get a request to my load balancer endpoint for sonar.greeton.ward, route that traffic to this Kubernetes service. So it gives us a way of doing reverse proxy to all of our services through these rules and annotations. And you'll see kind of why that's really nice to have once we get setting it up. But it essentially gives us a lot more flexibility in how we route things without having to manually set up port forwarding. So we definitely want an ingress controller. The other thing we're going to want to set up as part of this is some sort of external DNS controller. So whether that's like, what's a good, we're going to be using this external DNS operator, which I think is this one, Kubernetes things. And what this is going to allow us to do is when we set up a service and we say that we want, when we set up a service and we say it's going to be pointing at, you know, radar or argocd.my domain name, we want to make sure that our DNS that we're using will automatically pick that up, because we don't want to have to sync these things manually. So this is a project that was started and is continuing to go that essentially allows you to do that. So we can spin up any of these DNS providers and use them as our external DNS provider for Kubernetes. So if we can want it to keep it internal, we can use something like, you know, Pi-hole, or I think like Power DNS or Core DNS, something like that we're running internally. Or we can run these things, we can run these more externally and use something like Route 53 or Google's DNS. Since this is a Homelab, we want to run it pretty internally. We'll want to run the some sort of internal external DNS, which I know is a weird sentence, but essentially we want to run a DNS server in our cluster that we as the user are going to use as our DNS. So we also want it to be something that can that we can use as a real DNS server. I believe when I looked at this last time, Power DNS was probably the best one to use for that. See if I can find Power DNS. So we can figure out, we want some kind of DNS server. So Power DNS is what I think we're going to use. If not, Pi-hole does work as an option. It's not quite as stable. It's a little bit flaky. But we can find something that we can spin up inside the cluster to figure out what we need to do for this. So this is our kind of general infrastructure for like networking and routing and all that sort of stuff. And then we can get to the more fun applications that we want to deploy. So let me see if I'm forgetting anything. No, I think that's going to be just about everything we need. So we have ArgoCD set up. We'll actually put this here. So we have ArgoCD set up. So let's start setting some things up. So we'll start with Metal LB. And it actually has a customize thing that we can grab from here. So this customize will allow us to just build out Metal LB from there. So you can see one of the things when we were building with the autopilot, so ArgoCD autopilot app create, is we gave it this app. This app thing. And what that did is in our apps, our base just reaches out to this resource to build it initially. So we can do something similar where we want this to be in our production project. And we want to create an application called Metal LB. Let me zoom in here. And we want that app to be from this manifest. And let's see. We can kind of see, no, didn't like that. Okay, here we go. So yeah, this is what we wanted. So we instead want to deploy with this as our application. And that'll also pin it to the right application version. It didn't like that. Of course it didn't. So let's go and run this real quick. So we'll give that a minute to figure itself out. What we can see in ArgoCD, we have our Metal LB application. Oh. There it goes. So we can see all the resources that it's creating the speakers on each of our 3 nodes, and creating the controller. So this is our basic deployment of Metal LB. And once it's all good, let's see what problems it's having. Let's see what it's got. Oh, there it goes. So I was having issues for a minute. So now that we have Metal LB, so now we can go and look at kind of the documentation for Metal LB, and we can figure out what exactly we want to do here. So one of the key things that we want to be able to do is in our configuration is to be able to define this IP pool address. So if we go back to our Git repository, we can see if we download our stuff, we can see we now have this Metal LB application, which has a base pulled from here. And then we have our overlays with a configuration that's going to put it in the right path for everything. So what we're going to do first is docs added readme, just to make sure this readme gets committed, and we'll keep this updated as we go along. So part of our production now that we have Metal LB deployed into our cluster is we want to be able to give Metal LB a set of IP addresses that it can use to hand out as the load balancer. So we're going to tell it the IP ranges that act as if you were a cloud provider with an IP range and hand these things out as I ask for load balancers. So in my case, my lab is running on 192.168.5.0/24, the .5.0 IP range. So I want to run things between, 192.168.5. Let's say 200 and 192.168.5.250, let's say, to give myself 50 IP addresses that I can hand out as a load balancer. I don't think I'm going to use nearly that many, but, always good to have more than you want. How did I deploy the cluster? I set up some nodes, and then I used a Ansible playbook. Let me see if I can find it again. K8S, Ansible, TechnoTim. From TechnoTim, using this playbook. And it is really, really helpful because it also sets up having a single IP address for the controller. It's a really cool thing, and I might go into kind of how it's set up. But for what I wanted to do on stream, I wanted to focus more on, setting up the GitOps and all that. Because I think realistically, getting the Kubernetes side set up is one of the least interesting bits. But yeah, if you want to get started with that, you can use this to set it up in bare metal, or you can use my Linode code to get a lab set up on Linode, and you can run it for like 3 months for free if you have with the $100 credit. So something good to try and work out. But yeah, so for MetalLB and for my IP address pool, in production, I can make a new resource, which I'll just call my IP address pool, which is going to use that like MetalLB custom resource that it created to give me a certain range of IPs. So I said I wanted 5.200 through 192.168.5.250. So this is the range of IP addresses that I want to have. And I'll call this my lab LB IP range. So now I can have this, and with these IP addresses. And then what I need to do now is in my customize, I need to add this as a resource. Pool.yaml. So now it'll pull in the metal LB stuff, and then it'll pull in that resource that I created, which will tell it to advertise these IP addresses when you have a load balancer. So now that I have that, I need something to tell Metal LB how it's going to actually advertise these addresses. For my setup, layer 2 advertisement is super, super easy. So we're actually just going to add this into the IP address pool as a second resource. So we'll do the YAML separator here. And then I'm pretty much just going to copy and paste this and change the name. So this is going to be my L2 advertisement. That's how you spell advertisement, right? Yeah, great. That'll be deployed in the Metal LB system, because all of this is going to get deployed there. So we can see here. And I think that's really what we want to do. So now we have my IP address pool, and I have my layer 2 advertisement. And then we can pretty much try to deploy this. So we'll go to over here to Git. We can see that I have the customization and the IP address. So I'll add a new feature, adding LB IP range. And we can sync those changes up. And then we can actually watch in this ArgoCD application. Once it syncs, we should see in a little bit, this will get a new commit, and it'll start syncing the resources that we asked for. I believe this is on autosync. Yeah, this is on autosync. So we can just refresh it. And then it should pull in the latest commit. So let's see what we got here. It did say I was running out of memory, so it might be having some issues staying upright. It seems to be alright. Yeah, I know it's running out of memory. Let me see, because I did have problems before where it would like time out sometimes. There we go. Yeah, there we go. Now you can see the comment for my latest commit that I added the IP range. And you can see right here my IP address pool with what we configured. And my layer 2 advertisement here. So if we go over here into our system, we can see like IP address pool. We can see it here. And our L2 advertisement, we can see that described here. So let's see if we can deploy something where we can test if this is actually working. So let's see, does it have the managed fields? Setting no is interpreted as the instance being associated to all of them available. So yeah, that's what we want. So we should be good there. So what do we want to do next? I think we want to make sure that we can actually deploy this with a load balancer. So let's go and find just a random load balancer. That we can use. We can do that with our ArgoCD. So we can go into our ArgoCD and set it up to be a load balancer instead of I believe it's a node or just a node port or just a normal service right now. Can we? Maybe we'll do that later. But I do want to make sure that we can actually do something. So let's see if we have any of this base stuff. So let's go find this. And we'll see if we can override something there. Well, that's not right. And there we go. Examples, demo app. There we go. So let's look at the service we have here. So we want to override this service. And instead of making it, we want to make it a load balancer. So in our testing overlay, we want to make a customized patch. Where we're going to use something. I gotta remember how we do customized patches. It's like customize overlays, I think is what we want. So we got the base, and there's going to be some overlay. Yeah, so we'll make an overlay here. Service.yaml. And we're going to use kind of the same base as this of simple app, but we're going to change it to be a load balancer. And actually, we should be able to just kind of do this. So it'll just select based on that. And then I gotta remember how this actually works here. So you've got our base deployment that looks like that. Right, so I just should be able to just add it as a resource overlay in our testing. So we have service.yaml. And then we can kind of sync this up. Overlay load balancer on test service. And we'll go back to ArgoCD and look at our testing hello world. And I promise I will increase the memory for next time, but so we should see in a second it'll pull in the newest thing. Has an error. Merging resource from service that may not add resource that's already registered. Is that not what it told me to do? Customize overlay resource. Or maybe it's just patches. Maybe it's just patches. Yeah, that's what I'm missing. Customize patches. Come on here. Right, so I have patches. Alright, we'll do... I think this is right. We can actually test this if I do... I don't have customize. I don't have customize this all. Well, update, customize, customize patch, sync that up, see if that does what we're interested in here. So So now if we look at the service, we'll see that now it is type load balancer, and there we go. We can see that it's working because it got the IP address, the first IP address in the range that we told it. So I think that means if we go to 192.168.5.200, we should see, there we go, our test application able to be accessed through the IP address that we assigned it through our load balancer. Beautiful. So that, we can go to our, README here, and we can check off that we have now done the bare metal LB, and we are good there. Actually, before we go on, I am going to do that. I'm going to increase the memory right now, just because that's going to bite me later on. I'm probably also going to have to order more memory for this thing, because 16 is going to run out really fast. So I'll just increase it to 4 for now. What is it? 4096 for each. And I just have to restart these in series. So 4096. 4096. So we'll restart these one at a time. It'll actually be interesting to see how this affects our current deployments. Because we can see we have some deployments on everything. So let's see as we kind of restart each of these. Let's restart node 1. And just see what goes on there. And while we're waiting on this, I'll be a shill real quick. If you want to follow along and start working with Kubernetes, you can use the !Linode command to get my Linode referral code. If you sign up, you get a $100 free credit for, I think it's 60 days. So you can run a full 3-node Kubernetes cluster for that entire time for free. To follow along and play around with it. And it helps me out if you continue doing it afterwards. So let's see what we got here. So it looks like a lot of them just kind of stayed there. It's still going through its reboot. Ah, I know why. Because I didn't install the thing. Okay, well. We're going to have to do this a little more manually, but it'll still be interesting. Oh, did it actually do it? Yeah, okay, there we go. It did get the shutdown command. So we should see a lot of this stuff will start to kind of fail, and our node we'll see is not ready because it's offline now. Although it doesn't seem to have affected any of our workloads, which is interesting. But you can see we still have everything. So now that it's shut down, we can start it back up. And once it gets booted up and reconnected, it should have much more memory. Yeah, right now we can see like the memory it has is just 1964. I should have also increased the number of CPUs these things have, but I think we're way more memory constrained than CPU constrained, so I don't think that's going to be much of a problem. We'll see this thing come up in a minute. There's it booting up. And we should see in a minute, once it reconnects, that the memory has increased. Actually, I should be doing this. Yeah, so we can see way lower memory usage. In a second, we should see it reconnect as ready. Perfect, right on time. And we'll see that it's, you know, having trouble and having to restart and fix things up, but it was able to figure itself out, reboot, get everything up. So that's good. And we should see somewhere here we should see its memory. Come on, memory. Yep, memory, so now we can see 4 megabytes. So that's much better. So I'll actually go through, I actually will increase these to 2 cores each just while we're here. And we'll do a quick reboot while we're talking about the next thing. So what we want to do next is set up Longhorn. And Longhorn is going to be a little bit more involved to set up because it's going to go onto all of our different nodes, find the disk space that it has, and then offer it up as a essentially offer it up as space for the cluster to use. I really love K8S because it's a nice balance between like a Kubernetes UI and like, you know, raw Kubernetes commands. Yeah, like I can navigate everything. I can go to like everything really quickly, go drill into namespaces. Super nice tool. I highly recommend to anyone who's going to be using Kubernetes that you learn this tool as well, just because it makes you so much faster and it's not too far removed from Kubernetes commands that you feel like you're completely lost. But let's see. So what I want to know here, right, is can I deploy this with just a customize thing? That's right. .com. I want to look for Longhorn. There's Longhorn. So I want to see about deploying it with... No, you're good, man. I appreciate you chatting. It's nice to get some engagement. Let's see what we got here. I want to see... This is how you deploy it with kubectl. But can I deploy it with Customize, or is Helm going to be the only way? I have a feeling Helm's going to be our best shot, because it's going to be the most consistent way of installing it. But I think Customize has an option to essentially use a Helm chart as an input. It's I think it's technically a beta feature. Let's see. Yeah, the Helm chart, or the Helm charts field. So yeah, you can see like you can essentially use a Helm chart as a customized input, which is an interesting way to do it. But I think for Longhorn, it's the way we want to go because they don't have a good like customize output. We can kind of try. Let's see. So we go to Longhorn back here. You can see the chart. We can see the, where does it say the normal one is? Just Longhorn 1.51 deploy. I see. Well, that's not particularly useful, but is it deploy longhorn.yaml? That looks right. Right? Yeah, deploy longhorn.yaml. So this is just like a whole big thing. Let me see if I can do like customize GitHub resources. Remote build, yeah. Does it has to be a customization directory. Yeah, I didn't think so. Customize remote resource. Can reference remote files. Okay, so yeah, that's fine. So we can just use this as our remote resource. And then that should work. So we can go back to here. And let me make sure that, let me export the things again. There we go. So, we do ArgoCD autopilot app create. It's going to be based on that as its resource. And this is going to be called Longhorn. Let me make sure I don't have anything else locally that I'm doing. That's just README. Docs, update README. And let's see what we got here. So we can deploy. It's going to try and do that. So we might have to set this up manually, which is going to be fun. So okay, we have to do it manually. Fine. So let's copy our metal LB one and call it Longhorn. Because that's going to be all basically the same thing, and just make sure we change the right stuff. So Longhorn, Longhorn, Longhorn. We don't want this resource. We don't want to reference it. And basically, instead of referencing that, we want to reference... Where to go? This. We want to reference this Longhorn bit. Right? That's what it said we can do? Yes. And we can tag it to a version even. So we can do $ref equals. Send this over here, send this over here. Ref equals that. And if we look at the Longhorn, we were at ref equals v1.5.1. Perfect. And then we need a timeout, I think. Yeah, timeout 120. Just so that we don't sit there forever. So we got that. And I think that's really all we want to do, because we don't need to do much customizing of Longhorn itself, like outside of that. So I think that's pretty much all we're going to do, and we can push this up as a new feature. Like, this is all Longhorn. We want to give it in the right namespace, though. User given name is Longhorn. And I think this will create... I think this is going to create our namespace for us. Let's see, sync policy... I don't know. We'll see. We'll see if it makes the namespace. If not, we can add that in as a sync. So we're gonna do feature add Longhorn app. So let's check in our ArgoCD and make sure that that's all syncing. See if it has any errors. Right. I'm not doing that, so port forward again. There we go. So we can see Longhorn, it's syncing. Few warnings. Custom resource definition is part of production Longhorn and Longhorn? That seems fine. Not too worried about that. Not sure what it means, but I'm not too worried about it. So we'll give this a second to kind of spin up and run. Let's see here. So it seems to be running. Roll, that's taking its time. The deployer's taking its time. Let's see, all these custom resources. Not sure what the problem is there. Yeah, that all seems fine. You can go back in here. Didn't get a full restart, so it's still doing that. So it's probably that it's out of memory, so it's taking a really long time for it to do its thing. Let's see. That's fine. We just gotta figure out what we need to do. Yeah. Alright, here's what we're gonna do. We're gonna shut these down one at a time and do this. We're doing it live. Memory is my most important one, so I'm just gonna start here. It'll probably not break anything. We're not running anything critical there, right? That's in crash loop anyway, it'll be fine. No? You might have to play with the config a little bit, and make sure you actually have a K8S cluster to like connect to. So like your cluster context is all set up right. Because I've had it kind of work a little wonky for me, especially if I have multiple contexts. Oh, nice. Yeah, Docker Desktop for Kubernetes is a pretty nice setup, especially for local. Really helps you get going. And it does give you a lot. It gives you a few things for free. Like it'll do, I think it actually does load balancing for you. Like it'll spit out IPs for you to work with. Yeah, it's a great place to learn. Yeah, Docker is really focusing on making their desktop product as nice as it can be. Yeah, 16 gigs of RAM is, I mean, hey, I've got 16 gigs across 3 nodes, so you're doing better than I am. So, Chrissy, what I would check is make sure that, like, you can use the normal Kubernetes containers to... nice. you know, I'd make sure your context, just make sure like you can run normal Kubernetes commands first. And then once, like if you can confirm those work, then try to go to K8S, because it's basically just going to piggyback off of the same configuration that the kubectl commands are using. I haven't actually heard of that. What is that? What's this? Interesting. Yeah, I can see that. I can definitely see that using a lot of RAM. I haven't played a lot with vector databases. The only one that I've used is yeah. This is the only one that I've really used. Because it was the easiest one to get set up. But yeah, I'll take a look at that. Alright, we got one backup. Let's run the other one back down. Maybe this will start picking up something in a minute. Oh. Is it gonna crash? That's pretty cool. I'll have to check that out. I haven't done a ton with it. It appears to be having a lot of problems. Because it's still waiting. I guess it doesn't have enough. I'm guessing that it's the memory issue. And as I add more memory, this will become less of a problem. You know, I wish you the best of luck, man. Yeah, K8S is a lot to kind of take in and try to figure out. And I know there's a couple of like AI automations for like optimizing clusters and all that, and they do okay. They do okay, but it's a lot of automations, and I think DevOps is one of like the domains where it's just a lot of weird quirks you have to know. It's not really like this nice cohesive thing. So I don't know, maybe the AI will be really good at it. But I think it'll take it's gonna take a lot of data input to get it there. Let's see if we can kickstart this thing. Come on, bud. You know, I'd really appreciate it if it could take out some of the toil of my day. Nice. Let's see here. Yeah, successfully assigned. It all seems fine. Just doesn't want to start. Yeah, because this thing's got to go first before it will allow it to run all the other managers and things. Yeah, Kritzy, my day job is managing a lot of Kubernetes clusters, keeping a SaaS up and running. So I do this day in, day out. Nice. It can be. It can be kind of intense. It's just a matter of, you know, you kind of get used to the intensity, but then there's always the one thing that comes out of left field, and you just gotta know enough to get the thing back up and running. There's no error events, it's just stuck. We do have quite a few like security standards. I don't remember exactly what all of them are. But we've definitely got a lot of different security bits going in there. All right, thanks for the follow, Critzy. So yeah, I don't remember exactly what all of them are, and I'm probably not supposed to say them. But we do have like a whole bunch of security webhooks and admission webhooks and all kinds of stuff constantly scanning for, you know, making sure that we're using our best practices. Now, why is Longhorn being a problem? Let me double check something, because I've deployed this before, and now I don't remember how I did it. I did do it through Helm. Well, that's unfortunate. I don't understand, like, the resources all got deployed, so I don't understand why it's not able to do that. I haven't yet. I was studying for the CKA for a while. It was never something that I got around to. I probably will eventually, but like certificates, at least for me personally, are more of like the afterthought rather than the goal. Like they're super useful for being able to focus, like, all right, I want to learn this skill set, and they're really good at like giving you like, here's what you need to know. But I find just like doing stuff like this and just doing random stuff helps me learn much better than trying to like study for a test. So I studied for it for a while, but I just didn't end up taking it. Why are we here? Why are we doing this to me? Like, the UI is all there, that's all fine. Is there anything else that hasn't synced other than that? Let's try syncing this again. Maybe that's it. Maybe like this role didn't get done in time. So if you look at the sync, can we just say, all right, stop doing that. Sync this. Because I think if the CRDs were made beforehand, resource not found, cluster role, longhorn role. So let's see if the CRDs are somewhere. CRB, CRD. So Argo is, what's the best way to describe it? It's essentially a continuous deployment platform. So normally when you're working with like Kubernetes and stuff, right, you make like a manifest and you say, I want a deployment with this stuff in it, and you apply that. And then you get a little bit better at it and you start using things like Helm, right? You get a Helm chart, which has a bunch of resources in it, all packaged up. Then you can send, maybe you're using Customize. So, I mean, it can run any Kubernetes workload. So this is saying in, yeah, so Kubernetes is kind of the step above that, where instead of running individual containers, you're running entire orchestrations around them. So I can run 12 containers across multiple nodes doing all that kind of stuff. Yeah, sure. You can send it. I think I'm blocking links in the chat, but you can DM it to me and I can open it up. But yeah, the main thing for this is that I have a Git repository that has everything that I want deployed in my cluster. And what ArgoCD does is it looks at that repository and then makes sure everything that I have there is in the same exact way in my cluster. So instead of manually using any commands or, deploying a Helm chart or anything, I can instead just go through a Git repository, which gives a lot of benefits, especially if you're on a team, that you can have some sort of like control flow and things like that. Let me see here. Yeah, of course. Hey, nice, man. So we got a bunch of this stuff. So you got the Docker Compose, right? Yeah, with Weavite. It depends. If it's a server, you can pretty easily put it like in a Docker container and run it as a server. And then expose all that. CLIs are a little harder just because they're meant to have a person kind of in front of it. So yeah, I mean, you can Dockerize that and expose it through all these other things. Okay, yeah. So kind of like an Electron. Okay. So yeah, I mean, you can definitely do that. It's going to be... Yeah, if it'll launch the GUI, and then you can port forward out of it, and then you can take a look at whatever you want to take a look at. So let's see here. I don't know why this thing is taking so long. Let's see what errors it had. Failed to sync. Namespaces Longhorn not found. Aha! Into an exe? I haven't messed with that a lot. I think that'd be kind of difficult to do because Docker's meant to be like running it. It'd be kind of difficult to do. I guess you could bundle like Podman with it and run it that way. It's definitely not what Docker's for. At least, not that I'd use it for. But I use it a lot more on like the server side, so maybe. Yeah, we're talking about like running Docker on the desktop is definitely not in my realm of expertise. I'm sure someone's done it. Yeah. There's something for like auto sync. Create namespace, there it is. So what I want to do in my production when it syncs, right, is I want, I think it's sync policy, sync options. Yeah. It feels like something that's possible, but I just haven't seen it. Yeah, because like yeah, you can bundle Python together because when you do that, you're essentially just taking like, the Python, the program, and just bundling it with your code. So there's definitely ways to do it. Like Podman is a daemonless way of running containers, whereas Docker like requires the daemon and the service running in the background. So if you can if there's someone that's bundled like Podman with code, you could probably do that. I just don't know how nicely that would play with like actual GUIs and not web interfaces. Yeah, I mean you can get some of it. You can get some of that way. You're probably gonna get some of it still, just because you still have to bundle stuff with it. But I mean, it definitely is an option. Yeah, that's kind of the drag with programming. It's always something's always gonna break. So let's see. All right, now I made that. Cool. Yeah. Yeah, I wish you luck. People have been trying to make, the unbreakable application for years. Like if you look at the Linux environment, they had, what is it, like app images, they had what else? It was like app images, flatpak, snap, like every kind of thing that you could think of to try and do just that, of just like, what if we just write it once and then it's done? Yep. There we go. There we go. Yeah, definitely. There's definitely a lot of those, yeah. So what's in that system? Did I? I think I accidentally broke something. Destination namespace Longhorn system. That's what I wanted. All right. So that should fix some of them. I've messed with it a little bit. You can do it. There's obviously operators you can put in. There's a bunch of different stuff you can do. But you can essentially do like GPU shares in the same way that you do like CPU shares. It's a little bit more tricky, just especially if you don't have like the enterprise GPUs that you can actually split up. But you can essentially give a pod like a percentage of a GPU to use. Alright, everything good? I think we got everything good. I don't think it's not necessarily based on VRAM all the time. I think sometimes it is. There's like, it's weird. Like you can schedule GPUs. Yeah, like each one does it a little differently. So like you request like one GPU. Like it's weird. Like let's see NVIDIA's thing. So like some of them let you do like, yeah, it's like you request a GPU. So you need something that lets you like split GPUs on something. So like I know NVIDIA has something that lets you do like GPU fragmentation. So it lets you take one GPU and present it to the computer as like 5 or something like that. Yeah, I know, especially with like AI stuff, like having a massive GPU is super, super important. But it looks like I think we're good. So now there should be things like this should be in the right namespace. Yeah, it'd be interesting. You'll probably have to have some kind of server in front of it, because just connecting directly to the GPU farm over a network is gonna... You're gonna have some problems. You're gonna have some crypto miners. Like, even if you can get it done, you'll have all kind of issues with that. Okay, yeah. So I think... Let's see if anything is still running in there. Great. That's an option now. Okay. I mean, you can encrypt it in flight and use HTTPS. Like, there's lots of different ways to just send data back and forth. Like, IP tunneling is going to be the easiest one to work for your machine, but kind of as it scales, you need something a little more robust. Especially if you're going to run, like, it as a server. You'll want to have some amount of API where it could send, like, the query, right? And just send back the chunks. Yeah. So let's see. So now we should see. We have Longhorn. There we go. So now we can see how much data we have that we can use, how many nodes we have, all the cool stuff. There we go. So this will basically just take all of the extra space we have on our nodes and present it as like cloud-like storage. So now when we tell the Kubernetes, hey, I need storage for something, it can pull from any node and do replicas and all that kind of stuff. Yeah, it sounds like a lot. Let's see. So we got Longhorn. We now have the ability. We should have a storage class too. So like we go to storage. Yeah, we have a Longhorn storage class. So then there should be something like there should be something about like a default. Yeah, so Longhorn is now the default class. Actually, I want to edit this. Yeah, I mean, data security is always a fun problem. It just depends on what you're trying to, what you're trying to avoid, I guess. Maybe. Might be able to do that. I don't know, like, exactly how... I don't have, like, the exact structure in mind, but I mean... If all you're really moving is text data, you have, you know, every option in the world. I think I can even just do this. Yeah, it's possible. If you have, like, if we end up going down the road where, like, being able to run AI models becomes just, like, the way to do things, yeah, like, you'll have phones that can do some amount of AI processing locally, then yeah, it'll be pretty ubiquitous. But I think with that, we have Longhorn set up. So we've got our bare metal infrastructure done. Yeah, not yet. Phones aren't really known as the powerhouses right now. Yeah, I really like Longhorn. It's super helpful for like local labs. So instead of having to set up like having to have like a NAS that's giving out object storage or something, you can just have redundant storage on the nodes themselves. So like each of these nodes, we'll see when we set up traffic, like it'll replicate and do backups and like all the cool stuff you're really looking for. And you only need your Kubernetes nodes. Which, speaking of which, the next thing we need to do, and probably the last thing we'll do in this stream, is set up some basic traffic, just so that we can show like something. Because right now, if we look at like our services, one of the things that we'll need is for most of the stuff, like the ArgoCD server or the UI, for the Longhorn UI, for all these different things, we want to be able to just give it a domain name that we can access it through. Like, we don't want to have to give an IP address to every single service, because that's just not efficient. So instead, we can set up traffic. And that'll help us a lot. So I'm trying to remember where the documentation is. So Metal LB is it kind of takes a little bit of explanation, but like if we go to, I think they have like some visuals. So by default, right, Kubernetes doesn't have any external IP addresses other than the IP addresses of the nodes themselves. So like by default, if I wanted to expose a service from my cluster to the outside world, I would have to give it a node port, which means that I would have to pick one of my nodes and say, you're going to use the IP address of one of them. And so I can, and basically just say, this port on this machine maps to this cluster or this service internally. And that's okay, but it gets a lot to manage. What you'd really like to do is be able to hand out a dedicated IP address to a service that maps directly to a service. And if you're in a cloud like AWS, Google, Azure, Linode, whatever, usually they'll have a service for you. So if you make a K8S load balancer in any cloud service, it'll assign this an IP address. Yeah, I mean, it'll work with anything that accepts a connection. It'll work with this, because this is the infrastructure behind how you're deploying things. So any cloud service, if you create a service with a load balancer, it'll give it a external IP address from it. But since we're working on bare metal and I'm not a cloud provider, I have to set up some service that'll do essentially that part for me. So what Metal LB does is whenever I set up a service, yeah, I mean, you can get a lot of that with Kustomize, but that's like, it's like the deployment side is its own kind of, yeah, if you can, it's its own like rabbit hole. But yeah, when we deploy a service as a load balancer, I can give it a set of IP addresses and say, whenever I make a load balancer, give it one of these IPs. It's a few. That's a small lab. That's fine. But yeah, it essentially allows me to use my local bare metal Kubernetes stuff like it's in the cloud with actual external IP addresses. So I can automatically just spin off services as external IP addresses. So if I wanted to expose like an MQTT server or a torrent port or whatever, I can do that. But we don't necessarily want to do that for every single thing that's just using like HTTP, which is going to be a lot of the services are just HTTP ports. So we can deploy something called an ingress controller, which will only expose one IP address and can route all our traffic based on rules that we set up. So that's what we're going to try and set up now. So Kubernetes is kind of all this stuff. And we can pretty much do something similar. And this is going to be kind of interesting because it doesn't have just a, like with Longhorn and with MetalLB, we had a base that we could pull from. But in this case, traffic is just traffic. So we're basically just going to pull all these things into a new application and just build up from scratch. So we got traffic. No resources here. And then just making sure all this traffic, traffic, traffic. And make sure this is also traffic. I think that's everything. Yep. So we got to set up a couple things. A lot of these are going to be like CRDs. Or some of them are going to be CRDs. So discover running services. So we need a cluster role. So this is going to be for, we're going to make one called RBAC. So everything that has to do with traffic authenticating itself against the cluster, we're going to put in here. So like the cluster role, the service account that it's going to use, the role binding, and then we're going to make sure, so none of this is going to have a namespace because we're going to define the namespace as part of the customization apply. It'll all put all the resources in the namespace that we asked for. So this is our RBAC. So part of this is going to be rbac.yaml, part of our base. Then we have our deployment, which is going to be the actual traffic, code. We'll copy this in here and see if we need to change anything. Service account name will be that. The containers. So we should actually probably put limits on there. What's it like? Yeah, resources. Limits. I'm forgetting how the CPU limits go. 1 second. K8S resource limits. What's the thing? Not storage limits. CPU resource limits. Come on, just show me the example. There we go. So I think the limit, we're just going to put like 2, maybe 1 CPU on there. And memory, we're going to put like 1 gig on there. Because it's possible that it uses a decent amount. But there's a possibility that it uses a decent amount of memory just because with holding things in memory and doing certain amount of what am I thinking of? Like SSL certificates and doing caching and things like that. Like this, it can use a decent amount. And if it doesn't, we can go ahead and see like that it doesn't use it, and we can bring down the limits. But that's what I'm going to do for right now, and we'll do requests on it as well. So make sure it has at least 200 milli-CPU and at least 200 megabytes of memory. And this will be the 2 providers we start with, and we can kind of go through and configure this as we go. So what do we want to do here? So we want to provide a service. Service.yaml. And before I forget, so rbac deployment.yaml and service.yaml. So let's pull this in and think about how we're going to do this. So we have the web service, which is going to target the port in dashboard. But I actually don't want to put a dedicated service to the dashboard. I want this to basically proxy itself out. So I'm just going to have the web one. And then we can figure that out. So I mean, that's kind of the base of it. And let's see what we got. So yes, we have web, which is container port 80. And let's actually do this instead. I want to do... We'll start with just web. And then part of it as we can go through is like setting up SSL certificates and doing all that. We may or may not do that this stream. We'll see how well this goes. But right now, all I want to do is just set it up so that I can give this dashboard a domain name, and that it will give me the right thing back. So, make sure our customize is right. Yep. This customizes right. So we should be good to go for our initial deployment. We have API insecure, and the providers is based on the Kubernetes ingress. So we should be able to make an ingress that hits this service. Yeah, I'll take a look at that in a second. Let me see. So yeah, I do want a service for the dashboard. But it's just not going to be a load balancer. We're going to keep that internal. So then we should be able to add traffic deployment. And we'll see how well this gets on. Yeah, there's traffic, and we'll see how well it deploys. Let's see. What is it having a problem with? So the role binding required. Oh, it doesn't have... I didn't tell it what namespace to put it in. Although it should have done that. Destination namespace traffic. And in production, we told it to... Yeah, destination namespace. Nice. Namespace traffic, yeah. Yeah. I've played with a little bit of the self-coding stuff like AutoGPT and stuff like that. And they have some, there's some interesting development in it. Cluster role binding is invalid. I just feel like my reason cluster role binding. Oh, I have to have a. Alright. I'll do it properly, I guess. Why did I close the... Why did I close the documentation? Cool. Let's see. Yes, that's gotta be there. Okay, well. We'll do this then for right now. So this needs to be traffic namespace. I think that'll do it. Actually, no, I can do this. I can go into my overlay and do a patch on this RBAC. I can do things properly. I can take this cluster role binding definition and add the namespace here. And then in the customize, do it like that. So it's still agnostic there. So I can say add a name space patch to BRB. And then we can terminate this sync, start a new one, see if that does it. Deployment. Huh? Did I paste something wrong? One or more objects failed to apply. Reason. No, I did that. Invalid namespace. Required value. Oh, Alright, I gotta do the whole patch thing. Alright. I gotta do this thing. Okay, hold on. Yeah, it's like this thing. Okay. Yeah, this is what I'm looking for. Target. Can you bring that far back thing back up? Group version v1 kind cluster role binding name traffic role binding and then patch add I think is going to be path slash subjects slash 0 slash namespace value traffic. I think that's it. That sounds right. Maybe that's right. What is it like? It's like JSON patches to like it's like add. I think that's right. Yeah, op add path this thing, and then that sounds right. Yeah, because there's nothing there by default. Okay, so now I can delete this because it's not getting used. Fix added proper JSON op patch. And now let's see if I was right. Okay, so the role binding got it. Deployment in version v1 cannot be handled as deployment. Quantities must be What? What does that mean? Cannot be handled as deployment. What does that mean? Oh, does that have to do with my memory limits? Does it not like it? K8S memory limits. Oh, it's not MIB, it's MI. That's why it doesn't like it. Traffic memory requests. One more time. Why? Why does it not like it? I don't understand. More water functioning. That should be fine. Does it not like G? Alright, fine. I won't do that. I'll do megabytes all the way around. Fix traffic memory limits again. Can I resolve host? That was weird. Come on. I believe in you. Oh, did it? Yeah, it killed itself again. It's having some problems. There we go. Now we got traffic. So it's all good, and we've got one traffic set. So we're gonna leave it at 1 for now, and the only reason I'm doing that is because when we go to do SSL, there's a lot of weird stuff we have to do in order to do multiple replicas. So I'm leaving it 1 for now. But that means that we have the ability to go to our systems, go to our dashboard service, and forward port 8080 to port 8081 and see our dashboard. Perfect. So all this stuff is internal right now. We can see like our services. So what I want to do is add essentially an ingress for the dashboard that allows it to run and proxy itself. So I want this kind of ingress. To redirect any incoming start with a slash to there. So we're going to make something similar for the ingress dashboard. So if we go to our base and we make the ingress.yaml, and kind of pull this in, and we want to pull it against this service. So this is going to be the traffic dashboard. And we want it to not be based on that, right? We want it to be traffic. We want it to be a rule based on the host name. So let's see what we can do here. Yeah, rule host. So let's see. How do I want to do this? HTTP paths, all this stuff. Let's see. Let me look this up. Traffic K8S Ingress. All right, so I can do this. So based on the ingress, so I can say, so the rules, this needs to be, host is going to be, we'll just call this traffic.example.com, and I will fix this in a little bit so that we can basically just test that if this works. HTTP path / path type prefix. Maybe we want it to be exact. The backend service is going to go to our traffic dashboard service. I actually don't think we need service on there. That feels like unnecessary. And the port is going to be dashboard. And we'll make sure that port is named here as well. All right, this needs to be named web. So those are our two different services with dashboard. Actually, no, this does need to be prefixed because there's going to be other paths in the dashboard that we want to go to. So I can create this path. Like the / prefix path is going to take me to this dashboard as long as it is traffic.example.com. And that should set up what we want. Let's see if we can do this. So feature add dashboard ingress. And let's see what we get. So there's our service. Add a dashboard ingress, so it should be there somewhere. I may have gotten the port forwarding to Argo is very hit or miss. So let's look in. I don't see our ingress. Oh, I know why, because I didn't actually add it to our... Oh, I didn't actually add it to the customize, yep. Ingress.yaml. Probably fix actually added ingress. So now we should be able to see something. Let's see. There's our ingress. There we go. So now let's see. Yes, now we have an ingress for the traffic dashboard that is pointing at this. Let's see. Seems like it's fine. Let's look at our traffic dashboard, this one. So yeah, so we have host traffic.example.com, path prefix / goes to here. And that will now route any traffic from traffic.example.com to there. It seems like it's fine. I don't know why it says it's still loading, like still progressing. But what we can do now is I can go here and I can edit my host file. I need a sudo. Come on, work with me here. Fine. So I want this to go to 192.168.5.202. Traffic.example.com. Right. Now if I dig that, I should get, yep, there, perfect. So if I go to traffic.example.com, we get nothing. Oh, wait, no. There we go, traffic.example.com routes to the dashboard, which is exactly what I wanted. So let's double check. Did it actually, why is it not showing that it's fully done? That's what I would like to know. Like, we did it, we got it. But I want to know why it's saying that it's not. Class none? Let's see what's going on with this. Lighter configuration. Otherwise, ingress missing annotation having an empty value or traffic are processed. This IP will get copied to the status.loadbalancer.ip, and currently only supports that. I don't want to mess with that one yet, but so why doesn't it, like, it just claims like it never is progressing. I guess because this load balancer isn't set. So let's do this. Let's go through and set a few things. Like our ingress class, we're going to set that specifically to be traffic so that it gets that. It's going to be annotation. Traffic. Feature, add traffic annotation. So that this can try and get done. And async. So yeah, the desired manifest and the diff, yeah, it should have that. Should say sync. It's so strange. It's there. But it still doesn't have the annotations. Why? Let's see, ArgoCD, ingress, never healthy. Let's see. So in ingress, the status load balancer ingress list is non-empty with at least one value for hostname or IP. Okay. So I want traffic, K8S ingress, update, load balancer. So using it as an ingress. Let's see, there must be like some configuration or something. The Kubernetes service to copy the status from. When using third-party tools like external DNS, this option can be used to copy the service load balancer.status to the ingresses. So let me see, like if I go to my service, right, and I look at my traffic service, my traffic dashboard service, so the Kubernetes service to copy the status from. So I guess that would be, I guess that's like the, I would assume it's this service, because this is the load balancer service. To the ingresses. Yeah. So I do want that. So I want to go to, I guess, my overlays and make a new patch in for that. For my, actually, I'll just put it in the base because I think that just makes more sense. So if I take this, where'd it go? Yeah. And this is going to be traffic/traffic web, right? Yeah, traffic web. So I think that works. Let me just traffic ingress controller publish service. See. Can I find it's doing all that, blah blah blah. I don't care about that. I guess we'll just find out, yeah. So right, so there's this 192.168.5.202 goes to this traffic web, as well as this traffic dashboard, which means now it can be healthy. Maybe I need to this. Still not syncing. Why doesn't it want to sync? Where is it? There you go. So host is traffic, the address is there. It's able to be healthy. And I can see everything in the ingress correctly. So why can't I... Like, it's out of sync. Right, so force sync it. Let's do force replace. Why? That makes no sense. That makes no sense. Hold on. ArgoCD cannot sync ingress. Because now it's like, it's healthy. ArgoCD ingress always out of sync. But I still don't think it, like, it still doesn't have the annotations. I think that's what I need to do. Ingress class name. Go to the ingress. Instead of this, I want it to be ingress class name is traffic. Right? That makes sense. So yeah, on my ingress, I say that, and then we're good. So let's try this. Added ingress class. Right. Oh, okay, that did it. So yeah, now it's class traffic, host there. So traffic.example.com / will go to traffic dashboard port 8080 based on this load balancer IP. Right? So if I do traffic.example.com, I should get routed to Norton, which isn't what I wanted. Not HTTPS. HTTP can't be found. Huh. Well, that's different. (8080) to 8081. Now it's not there at all. Damn it, I broke it. Oh, because I did this. Do I want to instead switch to using CRDs instead of normal ingresses? I think I do. I think I want to do it with the custom resource definitions. All right. So then in traffic then, in my chart, I want there to be these two resources, the CRD definitions, and then the CRD RBAC. And then my ingress is going to be different. It's going to be the custom resource. Instead. So I don't want this anymore. I want the traffic API ones, which is going to be metadata, traffic dashboard ingress route. Not going to give it a namespace because that's going to be defined otherwise. Entry points, web, routes, kind rule, I can type, match, yeah, post, traffic.example.com, no middlewares, services, kind service name. That's what, like traffic dashboard. Port 8080. Don't really care about anything else. That's pretty much all I care about. So let's go feature, switch to Traffic CRD. And we'll see what we get. Does it not like the... Does not like it. Let's see. Oh, it's because I did. That's probably why. Resource typo. Let's see what we get here. Is it gonna do it? Seems like it. Okay. So that seems to have worked. So I should have something called an ingress route, which is configured with all the right things. So, still doesn't work. Still not showing up as a route. I don't think I have the provider on. That probably is an important part of it. Yes, that is absolutely right. So in my deployment, I'm probably going to say like -- providers dot, like not do it based on normal ingress, just based on the CRD. Should all be optional, right? Yeah, because everything else is going to be default. CRD ingress controller. Perfect. And then as soon as this gets synced, and now I still don't have it. Come on. Still doesn't see it. Yeah, Kubernetes CRD is that. Still can't find it, huh? Because it's being created. I can see the ingress route right here. In the traffic namespace. Host traffic.example.com, and it's not getting picked up. Is there something else I need to do? Enable the provider. Apply all the needed provider configuration. Right. So is there anything that's not optional? I don't think so. Optional late filter, optional arrays, optional token. So the ingress route definition. Service, the deployment. Right, that's all fine. Is it having problems with it? Like, I don't understand why it's having problems with it. Got this traffic dashboard which matches some things, and then attaches to the servers. That's the name of the service, right? That's the name of it. The port's 8080. What's the matter? Is it supposed to be something different? Traffic IO V1 Alpha 1. Yeah, that's all fine. So why isn't it finding it? Oh, does it? It doesn't have a service controller. Aha! It doesn't have a service account. That's why. No, it does. Hold on. What's this R back? Oh, well. That's what I have in here. I just needed to be allowed to watch a few more things. Okay. Fix traffic ingress controller RBAC. So now we can sync that, and that should do what it needs to do. Okay. God damn it! Why? Entry point web doesn't exist. Entry point web does exist. Doesn't it? Oh. It does not. That, you know, that would probably have been a good decision to do. Entry points dot web dot address equals 80. We'll do this. Okay. Sync that up. So now what? Get that. Perfect. Okay, at least we're getting something. What's the problem? Oh, right, that needs to be 8443. Or just 443. Fix traffic ingress ports. Hallelujah. Okay. Thank God. Okay, so now I can proxy things through ingress routes. That feels like a good stopping point. Like we got quite a bit done. We got the ingress controller set up and working. So you can do all of these different things. You know, we can set up these ingress routes so any domain that we can point at the thing, we can get done. So I think that's good. Update this a little bit. So I do think I'm going to call the stream there. It's been going for, what, almost 3 hours? That's a good amount of time. So thank you guys for watching. If you haven't already, drop a follow. If you want to start working on your own home labs and start working on your own cloud stuff, you can use my Linode code. Or it'll break. That's also fine. Really? There we go. So you can use my Linode link to go and sign up for $100 free credit on Linode, and it helps support here. So, see if there's a good person to raid here. Let's see, development, science and technology. Is that right, or is it software and game development? Let's say there's a good one to, someone good to invade. Let's see. Let's see. This seems cool.
Random one. If I do brick and grass, there's 3 here.
Alright, let's see.